So let's look at some positive feedback systems. Positive feedback systems are directional, like I mentioned. They're going to push things in a specific direction. When you have an output, typically it's going to increase the output. So a little bit of chemical is going to produce more chemical, which is going to produce more chemicals. And here's some examples I'd like to go through with you guys: blood clotting, childbirth, ripening, lactation. All right, so the first one is the blood clotting response. So these are red blood cells down here. This is a capillary. Capillary got a hole cut in it. These are platelets. It's a white blood cell, only ones that are nucleated. So these guys are gonna, all of a sudden, when we get in contact with oxygen, they're gonna start signaling out and releasing large quantities of chemicals. Those chemicals are gonna go throughout the bloodstream. And so a few platelets are gonna release clotting factors, which are gonna signal more platelets that come to the scene. When they arrive, they're going to send more chemical out. And so eventually we're going to have almost like a text chain or an email chain, where with one person reaching out to a couple different people, we're going to end up with thousands and thousands of platelets that are going to arrive at this scene very quickly. Very quick response. And again, that's directional. It's not bringing it back toward a central tendency. It's bringing it in extreme. Okay, so all these platelets are being forced or being told to form a plug here at the clotting site, and that's because of the amplification of the signal by this positive feedback mechanism. All right, the next one I want to go through is childbirth. So childbirth, we have up here, we have the uterus. Okay, so cervix, below the cervix would be the vagina, and so what we have is the baby is in the birthing canal. We're getting to a point where this has to go and move down through this cervical opening, and typically this is closed, but as the baby is coming down, it's going to start to dilate. Okay, so this opening is going to get wider and wider to allow the head to pass through that opening, and they measure this dilation as an indicator of how close you are to delivering the baby. Okay, the other thing that's going to happen here is the uterus is going to start contracting. Oh, got my eyebrow contracting too, but the uterus is going to start contracting. That wall is going to expand and contract, and it's going to be what we call a contraction. Okay, so that's all controlled by hormones that are released by the produced by the hypothalamus, and they're going to be released by the pituitary gland. In particular, in this case, the hormone is called oxytocin. So oxytocin is released as the cervix starts to loosen in increasing quantities, and so the contractions, the first contraction might be several minutes apart. It's going to get, the space in between each contraction is going to get reduced, and the intensity of these uterine contractions are going to increase. All of these things are leading down a path, a direction away from set point. Okay, and so the faster the contractions occur, the more oxytocin is released, and eventually what's going to happen is that baby is going to get passed down through into the birthing canal and out of the body. Okay, so I hope that everybody gets that this is a positive feedback mechanism. Again, more oxytocin, higher rate of contractions, which causes more oxytocin, pushing it in a direction. Okay, so fruit ripening is another great example. This one is in plants, obviously, and so if we have apples on a tree, what's going to happen is as this plant ripens, it's going to send out signaling molecules, in particular ethylene. Ethylene is a gas, so that gas is going to spread out in the local environment, and any fruit that's next to it is going to start to ripen, and as they ripen, they're sending out more and more of that hormone. That hormone is going to cause all of the fruits in that vicinity to ripen right around the same time, and this is going to flood the market really with seed and these ripened fruits, and this is a part of how the plant times out reproductive strategies. And if you take an apple now, put it in a bag with an unripened fruit at your house, you'll see that the ethylene produced by the apple will actually ripen the unripened fruit. Okay, pretty cool little experiment to try out at home. In addition, the expression "the bad apple spoils the bunch" is absolutely true. Once an apple becomes overripe, the amount of ethylene production is so high that that bad apple would spoil the bunch of apples that it's around. Okay, so hopefully everybody feels comfortable with that example. All right, the last one here is lactation. Okay, so in any mammal, what happens during pregnancy is that there's another hormone that's called prolactin. That hormone is going to cause the swelling of the mammary gland, and you're going to have milk production start to occur within that female. And milk is a very important part of all mammalian development. And what happens is the milk will be produced as long as there's a suckling response. So as long as the baby is feeding off of the mother, then milk will be continuing to be let down. Okay, and so the more suckling that occurs, the more prolactin is released, the more milk is produced. Okay, and again, this is an example of a positive feedback system. The stimulus is pushing the milk production in the direction where we have higher and higher outputs, the more suckling that occurs. If there were 2 calves here and the suckling was increased, there'd be more milk production by the female because of the amount of hormone that's circulating in her bloodstream. I hope all these examples have made sense. If you have any questions, let me know. Thank you. Have a good day.